Good morning, boys and girls. This is Miss A here. Today we're going to talk about lesson 11 for math. Our learning goals for today are: I can demonstrate the possible whole number side lengths of rectangles with areas of 24, 36, 48, or 42 square units using the associative property. Now, the associative property we talked about a few weeks ago, a couple in our last module, and we're going to dig into it again today. So we have our area here. So this is just review. To find the area, I know that I see this side length over here that says 3. So I know for a rectangle, the other side length would be right here, which would also be 3. And the one up top is the same on the bottom. So my 5 at the top over here is the same as the 5 on the bottom, and the same with the 3 and 3. So in order to solve this, I have to think, what equations can I make to solve this array or this area? So I know 3, one side length is 3, the other one is 5. So my first equation could be 3 times 5, as well as 3 times 3, because I know if that side length is 3, this side length is 3 as well. So how I would write it is, no matter what, this side length stays the same, so I have 3 times 5 plus 3 times 3. Just like I broke up the boxes, that's how I break up my equation, just like we would with the distributive property. So I know 3 times 5 is 15, and 3 times 3 is 9, so 15 plus 9 is 24. So next is my word problem. Now, we know for a word problem, we do read, draw, write, and those are the 3 things that we have to do when we're solving a problem. So now I need to read my problem. So the first thing is, the banquet table in the restaurant measures 3 feet by 6 feet. I have to think, what's important there? Okay, I'm going to read through and then go back. Or you can think, okay, in the restaurant, it measures 3 feet by 6 feet. I think 3 feet by 6 feet is important, so I'm going to underline that. So I underlined it over here. If you print out the slides, if you want to write it down, you can do that. But if you can remember this, then you're good to go. So next, I stopped right there. So for a large party, workers at the restaurant place 2 banquet tables side by side to create one long table. Now, in that sentence, I have to also think, okay, what's important and what do I need to know in order to solve this problem? So I think, okay, workers at the restaurant place 2 banquet tables side by side. That's pretty important. And I want to create one long table. So I would underline 2 banquet tables side by side and one long table. Now, we want to make sure we're not underlining the whole thing because it can be a little bit tricky and then we won't be able to see what exactly I'm trying to do. So last but not least, find the area of the new longer table. Now, in that problem, I have to think, okay, again, what's important? What would I underline? And I think I need to find the area of the new longer table, okay? So first, I draw up my tables, okay? If I know one table is 3 feet by 6 feet, I draw one table over here. And in my next underlined part, I know that there are 2 tables that go side by side. So these are my 2 tables that go side by side. Now, it kind of looks like a tape diagram. So I know this group is 3 feet by 6 feet, and this one must be 3 feet by 6 feet as well. So I have a total of 12 feet as this side length, and this one as 3. So just like we did with the area problem before, I have to think about my equation. I broke it down into groups of 6 and 6, right? So I have my total problem of 3 feet by 12 feet, but that's a little hard. So I did 3 by 6 and 3 by 6. Also because the side lengths of one table are 6 feet. Now I need to solve this. So I know 3 times 6 is 18, and it's the same for this. I bring down my plus sign, and 18 plus 18 is 36. Now, there's another way we could do this as well. Think about the associative property and what that means. What am I associating with? What multiplication problem can I do to associate it? Or how can I break this down to make it a little bit easier? So also for this problem, I did my read, I drew my picture, wrote my number sentence, and now I need my word sentence, which is the total area of 2 banquet tables is 36 square feet. So now for my second part, I could break it down into a group of 10 and a group of 2, because you know what, 6 and 6 may be a little bit hard, but I know for sure 3 times 10 plus 3 times 2. So I break it down into a group of 10 and a group of 2 because, you know what, 10 is an easy number. So I have the same thing when I solve it. Let me move myself up here. And I do the same thing that I did on this side with how I solve it over here. So I know that 3 times 10 is 30, plus 3 times 2 is 6. So 30 plus 6 is 36. And I always need my word sentence, and that is the total area of 2 banquet tables is 36 square feet. So my answers are the same. The only difference is that I broke this 12 feet by a group of 10 and a group of 2, and this one by 2 groups of 6. So we still know that they are both properties of 12, okay? So I know that 10 plus 2 is 12, and 6 plus 6 is 12 as well. So now I am going to write an expression to find the area of the rectangle. So this is where we're going to dig a little bit deeper, and I know that one side length is 3, the other side length is 12. And this is a little bit tricky. Just like the slide before, I have to think, what ways can I break this up? And how can I solve this? Because 12 is a little bit tricky, so I need to think about that first. So I think about writing an expression. And this is my number expression that I'm finding first. So I know I have to find 3 times 12. And I know for the associative property, 2 groups of 6, just like I had before, equal 12. So I have to multiply my 3 by 2, 3 by 6, but just like I did before, but this one, I just want to multiply these 2 together to make 3. So if I multiply these 2, 6 times 2, it equals 12, and I just bring my 3 up or down if you're solving it that way. So it's the same thing if I were to do 3 times 2 times 6, right? So if I do 3 times 2 is 6, and 6 times 6 is 36. So no matter how I put these parentheses, I know that I will be able to solve the problem. But that's not the case for all problems that we're going to solve, where if I move the parentheses from one side to the other, it may not be the case. For some, it may, just like this problem, but some may not. So I know down here it's 3 times 2 is 6, and I bring my 6 down because I didn't use that yet, and 6 times 6 is 36. So my common factor is 36 for this whole problem. So now I need to try to find all the possible rectangles to make an area of 36. Can you think of a strategy to make sure you get them all? So I have to think about all the things I know and what I can do to make 36. So my factors, okay, I know 3 times 12, 36, 6 times 6 is 36, but how else can I go through to get 36? So I need to go through and see all the different factors that I can make to make 36. And over here, I have 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. Now, some of you may look at this and say, well, Miss A, how do I know all the factors? Well, it's kind of like trial and error. So you go through and think, okay, 1 times what equals 36? 36. 2 times what equals 36? So 2 groups of 36. Can I break 36 into 2 groups? Yeah, 18. What about 3, 4? And can I break 36 into groups of 5? I don't think so, because my 6 is not a 5. And we know with my 5s, it's either a 0 or a 5. So let's keep going. And then we go to the 6s, 7s don't work, 8s don't work, and then we kind of repeat ourselves on this side. So we slowly go up and then down over here, okay? So now, with this, you are going to try to find all the multiplication facts that are associated with the area. So you have to think about the area, how I can break this down, and what factors go together that are associated together with my area. So your job will be to do the Lesson 11 assignments on Google Classroom. And if you have any questions, don't hesitate to ask your teacher. Have a great day.